In the previous video, we looked at redox half equations in acidic solution. Now, let's move on to alkaline solution. The good news is that the method is not completely new. We still use the same familiar balancing steps first and then make one extra adjustment for alkaline conditions. In this video, I'll show you the exact method for balancing redox half equations in alkaline solution. The key idea is this. First, balance it as though it were acidic. In other words, use the acidic method first. Then convert it into alkaline form at the end. This is the full method. First, balance the atom whose oxidation state changes. Then balance oxygen using water, H2O, hydrogen using hydrogen ions, and charge using electrons. Up to this point, the method is exactly like acidic solution. Only after that do we add hydroxide ions to both sides to cancel the hydrogen ions, and finally simplify any water molecules. Let's apply the method to a classic example. Permanganate ion MnO₄- changes to manganese dioxide MnO₂ in alkaline solution. We will first balance it using the acidic steps and then convert it into alkaline form. First, balance the atom whose oxidation state changes. Here, manganese appears once on each side, so manganese is already balanced. Next, balance oxygen using water. On the left, permanganate has 4 oxygens. On the right, manganese dioxide only has 2 oxygens. So, I add 2 water molecules to the right. Now, balance hydrogen. On the right, the 2 water molecules contain 4 hydrogen atoms in total. So, I add 4 hydrogen ions to the left. Now, I balance charge using electrons. The left side has an overall charge of +3 because +4 plus -1 equals to +3, while the right side is neutral. So I add 3 electrons to the left. That gives the balanced half equation in acidic form. At this point, the half equation is balanced, but it is still written in acidic form because it contains hydrogen ions. Since the question says alkaline solution, we now need to remove those hydrogen ions. There are 4 hydrogen ions on the left, so I add 4 hydroxide ions to both sides. That is the key alkaline step. The purpose is to cancel the hydrogen ions and replace them with water. On the left, 4 hydrogen ions and 4 hydroxide ions combine to form 4 water molecules. Now, there is water on both sides, so I simplify. Since there are 2 waters on the right and 4 on the left, I cancel 2 from both sides. That gives the final alkaline half equation. So the final balanced half equation in alkaline solution is permanganate ion plus 2 water molecules plus 3 electrons gives manganese dioxide plus 4 hydroxide ions. This is the big idea I want you to remember. In alkaline solution, do not invent a completely new method. Use the acidic balancing method first, then make the alkaline adjustment at the end. Let's now try a shorter second example to reinforce the same method. Hypochlorite ion changes to chloride ion. The number of chlorine atoms is the same for both sides. So first, I balance oxygen using water. So I add 1 water molecule to the right. Then I balance hydrogen by adding 2 hydrogen ions to the left. After that, I balance charge with electrons. The left side has an overall charge of +1, while the right side is -1. So I add 2 electrons to the left. Now I convert it into alkaline form. Since there are 2 hydrogen ions on the left, I add 2 hydroxide ions to both sides. The 2 hydrogen ions and 2 hydroxide ions become 2 water molecules. Then I simplify the water terms. That gives the final alkaline half equation. So the final alkaline half equation is this: hypochlorite ion plus water plus 2 electrons gives chloride plus 2 hydroxide ions. A very common mistake is trying to add hydroxide ions too early. That usually makes the balancing messy. The cleaner method is always the same. Balance it as though it were acidic first, then convert to alkaline at the end. So here is the full method one more time. Balance the atom whose oxidation state changes. Then oxygen with water, hydrogen with hydrogen ions, and charge with electrons. After that, add hydroxide ions to both sides to cancel H plus ions. And finally, simplify any water molecules. If you follow that order, alkaline redox half equations become much easier.